Hi, this is Wong Cho, and today I'm going to talk about case write-up number 2 for my MBA 280 class. And the subject line here is Nu-kote's approach to optimizing transportation. This article was written by Larry James, and this is particularly talking about linear programming and how Nu-kote use linear programming to optimize their transportation ways. So I would like to talk a little bit about company background here. Nu-kote is an international company, and it is the largest independent manufacturer and distributor of aftermarket imaging supplies for home and office printer jets. It produces inkjets, laserjets, and toner cartridges. And in total, there are more than 2,000 products, and they are used in more than 30,000 types of imaging devices. Currently, the headquarters is located in Franklin, Tennessee. All of its production is done in China, but the distribution to its clients are performed in the United States, and that is what is driving up the cost for the company at the moment. So why did I choose this particular case and decided to make a video about it was that it was very interesting to me that international business such as Nu-kote relies on linear programming that's created in Microsoft Excel to optimize their transportation. I would figure a company this size would have a better tool or fancier tool than Microsoft Excel to do their optimization, but they're using Excel to do their modeling, which is quite interesting to me. And it was also interesting that it can be very effective in driving down cost and really optimizing what they needed to do. So here's the situation right now with Nu-kote. Currently, Nu-kote fills customer orders from its warehouse in Franklin, Tennessee, and 80% of the products are manufactured in Chatsworth, California, imported from China through the port of Long Beach. And currently, there are very few customers from Long Beach itself, so they have to carry all the products into Franklin, Tennessee from California, which is additional cost that they have to incur. And they also need an efficient way to plan shipment of finished goods from the vendors that they're partnering with, from the manufacturing plants, warehouses, and customers to minimize overall cost. So big thing for them, obviously, is driving down cost. And with the economy right now and the price of gas, this is a big thing for a lot of manufacturers and the distributors around US. And they have done some studies of prior supply chain optimization to see which method is actually the best for them, so that they can model after the successful one, so that they can make their optimization smoother than anticipated. So here are some of the tasks that they had to overcome, and the main objectives. Here are the 4 main objectives that they were trying to achieve. And the first one here is to find the least expensive way to transfer products from their origin to the customers. And this is taking into consideration the holding costs and the handling costs as well. And the second objective is to provide acceptable responsiveness to customers. They don't want the customers to wait a week or two to receive their products. They want it to be shipped to the customer in 2 to 3 days optimally. So this is their second goal here. And they also want to know how much is it going to cost based on the radius from their distribution center, which is in Franklin right now, to wherever the customers are located. And the fourth one here is, would it be effective for them if they use the additional warehouse for outbound shipping of finished goods to customers? So basically, would it be efficient if they opened up another distribution center on top of the Franklin location that they have now to minimize cost? And here are the actions that they have taken. Nu-kote decided to use Microsoft Excel, as I explained before, rather than the algebraic one, because of new course managers like to think in terms of spreadsheets rather than formulas. Compared to algebraic formulas here, spreadsheet optimization model have a disadvantage, taking longer to solve, but with the speed of modern systems, it's just a matter of seconds, if not minutes, right? So as computers get more powerful, this advantage will be definitely a better way to go. And the development of the linear programming model were broken into 4 steps. The first step was to study Nu-kote's facilities within its current supply chain system and collect the data for the model. So all models that we need to create will have some type of data that's going to be driving it. So the more data that you have, better model you can create, which means that you get a better result in the end. So this is the first step that Nu-kote put in place. And the second step that they have taken was analyze the transportation cost, gathering data for Nu-kote's less than truckload and truckload carriers, and using regression analysis to the freight cost relationship. And the third step that they have taken was to design and develop a spreadsheet linear programming model to minimize costs, given a warehouse configuration and a maximum warehouse to customer shipping radius. So validating model's accuracy is what they were trying to achieve here. And this will also help them determine if they need to open another distribution center to drive down cost. And finally, the last step that they had to do was put in a different model and see if they get a better solution. And Nu-kote's model had between 5,000 and 9,700 variables and 2,400 constraints. The exact number of variables depended on allowable shipment radius and the number of warehouses allowed for the outbound shipment. So as you can see, this had a very extensive amount of variables that the model can play around with, and a lot of constraints to give them the optimal solution for their model. So in class we have played around with maybe 5 or 6 variables and about 5 constraints. So you can really see the size, the scale of the model here is really more extensive than what we have been doing in class. And you can just imagine how long it will take to develop that model, gathering up the data and so forth. So it is pretty extensive that they have done this in Excel itself. So here is basically the model that they have put together. Anything that's bordered around dark black here are the variables that they can play around with. And the cell here at E99 is the objective function. So basically you want to be minimizing cost. So in Excel, using solver, perhaps you'll be setting this to minimum instead of the maximum objective function. And we can also see the vendor constraints here. And the vendor constraints are basically driven off the capacity of the vendor, and this constraint here will fit into the overall model to drive that minimum cost objective function. And overall results, it's quite impressive what they were able to achieve. So based on the solution to the linear programming model, Nu-kote management decided to expand the warehouse to make the outbound warehouse as well as the factory warehouse. So this one here is down in Long Beach, California. So instead of shipping everything from Franklin, now they'll be shipping out of Long Beach as well. In the solution, many customers will be receiving their shipment from two warehouses rather than just single warehouse like it was in the past. So Nu-kote communicated this change to the customers, um, and the customers were basically bought into the idea of what the Nu-kote was presenting. And the new system that they have put in place is going to reduce the annual transportation and inventory cost by approximately $1 million. Now that is impressive just by creating a model in Excel and creating a solution in Excel itself that can really help the company $1 million in transportation cost. And it also reduced the customer transit time, and many of the customers will receive uh, their shipment in about 2 to 3 days, which is quite impressive. And so this optimization modeling, has been a catalyst for Nu-kote, the company itself, to have them thinking of different ways, basically driving off of the data, a proper data set, so that they have all the information that they need to create the model, and basically running the model to find the optimal solution for whatever they needed to do. So I found that very interesting, and